Okay guys, we are looking at more differential equations, first order differential equations from Math 6. So the starting point is always to write your differential equation in this format, which is a formula on page 7 of your formula sheet. So that will be our starting point. So when we look at this differential equation, the nice thing is that it is already arranged with two terms on the left, one on the right, just like the formula. dy dx is also alone, so our target is to get the negative, to get the positive in place of the negative. So I'll just do a little bit of rearrangement there. So I'll put my positive sign, then this negative sign, this is how I will treat it. It will become negative 1 over x. So that is the position of p, just like you see there. Then it's equal to our x e to the power x, and this is our q. So once you arrange your work to look like this, and it resembles that formula, it means you are good to go. Now the next formula you must target is y e to the power the integral of p of x dx is equal to the integral of q e to the power the integral of p of x dx. So once we are done with the first formula, that should be the next target. So this one, I like doing it in bit, so I will do this portion first, which appears on both sides. That means I've picked my p already, so I'll get the integral of negative 1 over x dx, which obviously is negative 1 ln x. So it means I'm done with that black circle. Then I'll go to the other part, which I'll put it in a rectangle, so it also appears on both sides of the formula. We always call that the integrating factor. So my integrating factor, my definition is e to the power the integral of p of x dx, and from the previous step I've done that part here. This was the integral of p of x dx. So I'll just slot the answer here, which is e to the power negative 1 the ln of x. This negative 1, you have to apply the law of log to take it to the exponent, which is e to the power the ln of x to the power negative 1, and that will give us x to the power negative 1, which is the same thing as 1 over x. So that is the law of exponent that we expect N6 students to know very well, that each time you get e to the power the ln of 2, your answer should be 2. If you try that in the calculator, that is what you will see. But if you get e to the power 2 the ln of 2, then you will see that this will be e to the power the ln of 2 squared, because you have to apply a law of log there, and this will give you 2 to the power 2, which is 4. So those are basic laws of exponent and logarithms that we expect N6 students to know. So with this, I've managed to get the IF, which I will then use to replace the rectangle on both sides. So if I get back to my formula, on the left I will put in 1 over x times y. On the right, it's the integral of q. You still remember your q, it's x e to the power x multiplied by IF, the integrating factor, which is 1 over x dx. So this will take care of that. So the right side reduces to the integral of e to the power x dx. The left side is simply y over x. Then if you integrate that, you will be getting your y over x is equal to e to the power x plus c. So this is what we call our general solution. So if a problem was saying solve for the general solution, you obviously end it. But immediately you see a problem giving you conditions like x equal to 1 when y is 0, and they are looking for a particular solution. That means you must solve for c by replacing x by 1 and y by 0. So if we do that into the general solution, we'll get 0 over 1 is equal to e to the power 1 plus c. So that simply tells us that our c is equal to negative e if e goes that side, which is also approximately equal to 2,718 if you check with your calculator, but you're free to use e. And therefore, a particular solution means you will copy the general solution, then in the place of c, you put e. So that's the solution, the particular solution of that problem. So if you're fine, we can then switch to the next problem. So again, our starting point is to rearrange the problem to look like the standard form. So the standard form of a first order differential equation looks like that. So again, you can see that the first two terms on the left match the formula, the right is like that. So the only problem is that dy dx need to stand alone. So we need to take care of this too. And also need the positive sign in place of the negative. So my first adjustment will be to divide f1 by 2. If I do that, I'll get dy over dx left here. Then I will replace this negative by a positive to get that. Then here, you remember I'm dividing every term by 2. So 6 divided by 2 becomes 3. But don't forget the negative is going in to create space for the positive. So that it should be a perfect match for the formula. And I get my x minus 1 times y. Also divide that side by 2, I'm left with x minus 1, or that square. So here I get my p, and then I get my q. So I'm now ready for the next formula, which is y e to the power integral of p, a function of x dx, is equal to the integral of q times e again, the integral of p, a function of x dx, then all that dx. So I'll use that next formula and we'll sort it. Again, I will do it part by part. So I start with this quotient, integral of p. So this means my integral of p is simply the integral of negative 3 over x minus 1. Negative 3 are constant, we step out, I get 1 over x minus 1, which gives me negative 3 in x minus 1. So I'm done with the circle there, and then we go to the integrating factor, which appears on both sides of my formula. That's my integrating factor. So the definition of integrating factor is e to the power the integral of p dx. The integral of p dx, we've just done it. It's e to the power negative 3 in x minus 1. So we need to apply the law of exponential logarithm there to take the negative 3 to x minus 1, so it becomes e to the power the ln of x minus 1 to the power negative 3, and that becomes x minus 1 to the power negative 3, then not to, which is the same thing as 1 over x minus 1 squared, cube, sorry, to the power 3. So we are done with our IF. Integrating factor, so we can go back to the formula and slot it here on the right and there on the left. So on the left side will simply become y over x minus 1 cube. If we put this one here, then on the right, our integrating for our q, you see up there, it's x minus 1 squared. Then our integrating factor gave us 1 over x minus 1 cube dx. So if this simplifies, we'll be left with 1 on x minus 1, since the square will reduce the cube to x minus 1 dx. And if you integrate that, that gives you the ln of x minus 1 plus c. So that's what we call our general solution. So for the particular solution, we use the conditions again, set at 3, 1, that means x is 3, y is 1. So if you substitute there, y you are 1, x you are 3, 3 minus 1 is a 2, 2 cube, 8 is equal to the ln of x is 3, 3 minus 1 is ln 2. So that's the ln of 2 plus c. So to get c, we simply use our calculator to check what is 1 over 8 minus ln 2. So it tells us we have negative 0.568, negative 0.568. And therefore write the particular solution by recopying the general, which is y over x minus 1 all that cube, then equal to the ln of x minus 1, then minus 0.568. So So guys, that's how you get a particular solution. Thank you very much.